I don't have any problems. I got all the clarification I needed.
Okay, so someone in the chat said buffers. So, hi, good evening to the ones that has now joined. Good evening. I guess Mr. Akil Grant is Donovan.
Good evening, Miss.
Good evening. We have just started. And my question was, anyone with any problems or any topics that we need to discuss? And Miss Walters said buffer, right? So, may I ask the question, what is a buffer? What is a buffer? Can someone tell me? So you all can show your hands. So today I think that we close the exam. I could just pick out anybody. Do you all agree to that? Or do you all disagree? So we can have like, oh, okay, so I have one person replying with a thumbs up. Okay, Miss Davidson, Miss Destiny. Good evening. Can you speak? Miss Jagan, are you online? Can you speak? Anybody would like?
Hi, good afternoon, Miss.
Good afternoon, Miss Rose.
No. Chewing buffers are substances that in solution maintain a constant hydrogen ion concentration despite the addition of acid or base.
Nice. Yes, that is the meaning of a buffer. Everyone heard Miss Rose?
Yes, no, I didn't hear clearly, Miss. Could she repeat?
Yeah, no problem. Miss Rose,
Sure,
can you
no
repeat what is
problem.
a buffer?
Sure, no problem. Are substances that in solution maintain a constant hydrogen ion concentration despite the addition of either acid or base.
So, where Miss Rose would have got her answer is on page 23 of the, now I have the 41 page handout because it is the compilation of all the handouts, right? And I minus the cannulation camp because you know that you all are not doing that. I put that to the back of the handout, but nonetheless, I still have the pages intact. So she would have gotten that answer on page 23 under the question, what is a buffer? And that's what you need to know, right? And that first two lines there. So the ones that do not have a handout in front of them, how many persons are online without the handout or with no access to the handout? You can show by a raise of hands, please.
Is that yours? Is that yours? No? Stop provoking each other. Stop Please have a provoking spirit.
But don't be the child.
Oh, stop.
Miss, could you repeat what page it's on?
Sure, no problem. The page is page 23. Okay, so only two persons don't have their handouts. Would you all like me to share the screen? I could get a
Sir, page
yes.
23 of which handout?
The 41 page handout. So now you all see my screen. I have it up here because some people don't have it. So I want everybody to be able to be on track, and I don't want anybody to be lost. Anybody who is lost, see, Miss Sarah or Sarah, you're talking too fast. You know something, right? It is right. Look, it is right here. So you all seeing it? It's not zoomed up too much, right?
No, we seen it.
Nice. Okay, so that would be a meaning there. This would be a meaning here. Buffers are substances that in solution maintain a constant hydrogen ion concentration despite addition of either acid or base. Right? So remember, all your answers is right in your handout. So we are going to be finding the answers this evening for the ones that are lost. Everybody has got it?
Yes.
Any other questions?
Somebody asked what advantages and disadvantages.
What are the advantages and disadvantages of?
I don't know. Somebody asked that in the chat.
Okay, what? And they don't have any advantages and disadvantages of buffers. Buffers is all over your body. Buffers are all over your body. You can Google it and you can see, but it's not really relevant. You understand? Once you know what is a buffer, but buffers are all over our bodies to help maintain pH. But I would say a proper pH, right? Because that's what it's for, to maintain the pH between acid and alkaline.
Miss, is the same as acetate buffer. It refers to the same thing.
Yes, but yes, because yes, acetate buffer to acid buffer. So when the let's say I want to keep, it's always keeping it level. So let's say acid, but like the acid buffer and the bicarbonate buffer, right, to keep the pH level. If the if the acidity is higher, to make the solution, your blood solution, more neutral, it you say, oh, let off bicarbonate, say bicarbonate buffer will send out bicarbonate, you understand? So then it will reach our equilibrium. So yeah.
Okay. Miss, so you could put that as an answer if the question is given like that they are to maintain pH balance.
Yes, yes, because that is on page 23. It is right there in the meaning of what is a buffer. So any other questions?
Yes, miss. Good night. You can hear
Hi,
me?
Bishara. Good night. Yes, I can hear you,
Okay.
Bishara.
So right above this, right, it have the pH value, right? Now, I know in normal pH, anything below 7 points, anything below is alkaline and above is acidic. Is it that different in this way here?
No, is
Because the saying
what
if
I
the
said.
pH is less than 7.35, the solution is clearly acidic. And the H plus is increased. And if it's greater than 7.45, then
Yes,
it's
so the
alkaline.
hydrogen. No, but Well, this is just probably like the more precise calculation to it, or the more precise answer to it. Because yes, we know the pH is 7, but it is at 7.4.
So basically, this is just for the pH hydrogen only.
That's what I say here.
Is it just for hydrogen only?
Excuse?
Is it just for hydrogen only?
No, it is hydrogen ions. That is what is make acids.
Okay.
I believe so. Because it's hydrogen ions. Okay, someone has to go through the hemodialysis procedure. So, what do you all understand by the hemodialysis procedure? Can someone tell me about the hemodialysis procedure? So nobody knows the hemodialysis procedure.
Yes, miss.
I'm waiting for someone to tell me the hemodialysis procedure. Thank you very much. I'm listening to the rat. Good evening.
Good evening, just so that is
No
when
problem.
you're talking about the hemodialysis, the procedure, you're talking about the dialysate and the machine and the negative and positive pressure and thing, yeah?
Yes.
Okay. So the access, it starts with the access from the patient. It is negative pressure. Dialysate firstly is negative. The pressure to the tube, for the tubing to the pump is negative, and then when it reaches the pump, it becomes positive. And it remains positive to go back to from the machine to go back to the patient. And it goes back to the patient through the access, basically.
Yes, Kadiran, that's all that you have?
No, that is just what I have on the top of my head right now.
Okay, nice.
Because that is what's sticking my head
correct.
from what's explaining.
Miss, I could add to it.
Yes, yes, we need additions. No problem, Kadira. Yes, it is. And it was a good try, right? All that you probably didn't remember. Well, I let the others fill it in before I speak. But it was good. You just left out a few stops. Siwana, you could do some add-ins.
Yeah, so basically hemodialysis uses a dialyzer that acts as a artificial kidney. It helps filtering blood and removing waste products, excess fluid and electrolytes. The filter, or what you refer to as the dialyzer, uses a semi-permeable membrane to separate blood from a special fluid called dialysate. Dialysate, which draws out waste from the blood. The filtered blood is then returned to the body. This artificial kidney is a filter encased in plastic and inserted into the dialysis machine, but because it contains a semi-permeable membrane, it allows small waste molecules and excess fluid to pass through, but it does not allow blood cells or large proteins. I have more, but I will let somebody else add to it.
No, Tiwana, you could continue.
Okay.
It was
On
really interesting. Yeah.
On the other side of the membrane flows a special fluid, as previously mentioned, called dialysate, which is carefully prepared to contain ideal concentrations of electrolytes and other compounds. Filtration in hemodialysis occurs through two primary processes called diffusion and ultrafiltration. Diffusion allows small waste molecules like urea, creatinine, and potassium to move from an area of high concentration in the blood to a lower concentration in the dialysate, following the concentration gradient. This process efficiently clears toxins from the blood. Ultrafiltration, on the other hand, is the process of removing excess water by creating pressure difference across the membrane. Usually using negative pressure on the dialysate side, water is drawn out of the blood and into the dialysate. This helps control fluid overload in patients with kidney failure. That's all I have.
Okay, right. So, well, yeah, at least you have up till what happens in the dialyzer, and you know that after the dialyzer, the blood returns back to the patient, the clean blood, right? It returns back to the patient through the venous access. But I haven't heard that the blood leaves on the patient through the arterial access, right?
Yeah.
As yet, and just remember, you'll have to state the arterial access and return by the venous access. So anyone else would like to tell me the hemodialysis procedure? Sarah, your hand is up. Ramkaran. Andre, I see you online. Good evening. Are you able to speak?
Good afternoon. I'm here.
You would like to tell me your understanding of the hemodialysis procedure?
All right. Hemodialysis procedure starts with the arterial access from the patient. It goes to the dialysis machine, which will go to pump, then to the dialyzer, which will clean the blood using dialysate. After the blood has been cleaned, it will go from the machine back to the tubes and enter back into the patient through the venous access. The dialysate is responsible for removing excess water and toxins or waste products from the blood. The artificial kidney mimics the process of the kidneys. Right now, I'm working, I don't have none of my notes on me, so I just pulling off the top of my head.
Okay, but that is again from the top of your head, right? And that's a good thing because you know you could speak of what you remember and how well you remembered it. Miss Davidson, I see your hand up. You would like to speak?
Yes, no, sorry, I was earlier on. I couldn't talk.
Okay.
The process I have in dialysis, the blood filled with toxin and other waste products is filled from the arterial access by negative pressure by the pump. When the blood reaches the pump, the tubing wraps around and the pump causes the tubing and the tubing causes the pump to squeeze and creates positive pressure. The blood leaves the pump and goes to the hemodialysis machine and ends up in the dialyzer, where it is filtered and an exchange of waste substances and excess fluid for electrolytes and good stuff. It is then from the dialyzer, it goes back. Okay, where's that? From here, in the dialyzer, dialysate is under negative pressure. The positive and negative pressure meet in the dialyzer, and the pressure becomes positive. So this is called the transmembrane pressure. And the blood is returned to the patient through the venous access under positive pressure.
Nice. Well, you all know it's tough. Everybody else on online is on track with the procedure. Everybody who is on track with the hemodialysis procedure, please show by a raise of hand. There are 49 of us here, not 4 or 5. Okay, so I have 10 people. 1, 2. So what is the problem with the procedure that you all, the ones that don't understand, what do you all not understand about the procedure?
Yes, good evening. The procedure and this thing, I personally find it, I speaking for me, I find it simple. We just have to read. Basically, we just have to read. Everything is there. And it's not no math calculations, nothing. We just have to read. I know the procedure very simple. Dr. Michael broke it down for us last class. And I believe he broke it down for us on Tuesday. All we just had to read, you know.
Okay, thank you, Donovan.
Good
Yes,
evening.
we just have to read. Good evening, but it's not just a matter of reading, it's a matter of reading and understanding also. And I will always say, if Dr. Michael went through something with you guys, it is always good to go back through your lecture and see. So, Miss Nikisha, you can go ahead and speak.
Okay, concerning the dialyzing, well, dialysis process, is it that when we explain, do we have to include the positive and negative pressure, or could we just run through it from the arterial from the
By
patient?
including the positive and the negative, by including the positive and negative pressure, it does give him more marks. So it's
Okay,
marks
then
are looking for pointers.
okay. So for me, where when they break it to break it down simpler, could you all explain where and when does the positive and negative pressure is applied? Miss, I could explain it.
Okay, no problem. Take your time, Kitty. Go ahead.
The positive, the negative pressure comes from when the machine is pulling the blood from the patient because it's suctioning blood from the patient. Right? So that is negative pressure. So it goes to the tube, and then when it reaches the tube, when it reaches the pump, the pump is squeezing, the tube, and then it becomes positive pressure, right? So it comes out negative
I
from
just
the
want to
patient.
just interject right here. Please just pause. When they say the pump squeezing, now the pump is something that does be just going in a circular motion, right? And I don't know if you all watch the dialysis machine in the school, in your classroom, right to the front, and you will see the pump it is just be going circular. So by that pump rotating in that clockwise motion, it is like, okay, it was sucking from the patient in the negative pressure, and when it turn in that the clockwise motion after when you're going through the pump is a positive pressure, because it's like it's carrying the blood. It's carrying the blood forward. I just wanted to add in that piece clear. I could continue.
Okay. So when it reaches the pumps, it becomes positive pressure, and it doesn't change after that. It goes into the machine, the blood is cleaned, and it comes out as positive pressure from there, and goes back to the patient, because the patient is now getting cleaned blood. So that is basically it into the access, the arterial access. I don't know if that's simple enough.
Yes, that is correct. Everybody agree with that?
Yes, miss.
Yes.
That is correct. Miss Nikisha, is it? Did you get that?
So
Miss Nikisha is
basically,
still online.
I just saying from what I gather, right? So basically, it is the negative pressure is when the blood is pulled from within from the patient into the tube, and when it reaches the pump, it becomes positive pressure and
Yes.
returns to the patient.
Yes.
Yeah, it's not becoming positive pressure to return to the patient, but it continues to go with positive pressure towards the dialyzer. You understand? And when the blood reaches the dialyzer, that's when you will speak about it have the blood goes through the blood circuit, and then it have the dialysate circuit, right? Within the dialyzer, there's the blood circuit and the dialysate circuit, and you talk about the diffusion and osmotive, the convective transport that takes place within the dialyzer, right? And the blood is clean and continue to go back to your patient with positive pressure.
Okay, thanks.
With us, right? Anybody else?
I have a question based on what you just explained there. So basically, is like a push and pull motion. Well, pull and push motion. With the pump, with the rotation, it pulls it when it compresses the tube and it pulls the blood, and when it makes the full rotation, it pushes the blood. From negative to positive. Positive is the forward movement, right? Going right so
Yes.
far? So when it goes
correct.
to the dialyzer, the ultrafiltration and convection, the gradient force. One is the flow, and next one is applied pressure to go to the semi-permeable membrane. All that is coming from that pump, from that positive pressure the pump releasing when it pushes the blood forward.
No, what the blood is pushed to the dialyzer through the positive pressure, and when the blood reaches to the dialyzer, the blood is cleaned via the process of osmosis, diffusion, or convective transfer, right? And then when that happens, it continues to go to the patient through positive pressure.
Because my mind was well, right, the positive pressure coming off of the pump to the dialyzer. When I'm thinking about the ultrafiltration and convection, remember I said that the ultrafiltration is using a pressure gradient, right?
Yeah, so to remember, it's two different circuits is the blood circuit and the dialysis circuit, the dialysis circuit, right? So the pressure that is the blood passing, remember the blood passing through the blood circuit, and whilst the blood is making its way through the blood circuit, right? Through osmosis and diffusion and convection, the toxins will be being removed, but the pressure that the blood is being passed through the circuit, right? It is one pressure to go back, because remember the pump rolling, so the blood continue to pull and the blood has to go back. It's not just that, okay, that one motion, remember, blood will continue to be pulled from the patient, continuously going through the blood circuit in the dialyzer, continuously being washed within the dialyzer and returning to the patient, right?
Right. So the next question I have now, I understand that. So the next question I have now with the dialysate, when it reach good balance, right? Between the blood and the dialysate.
Equilibrium.
Equilibrium. And the dialysate goes to the drain, carrying the toxins and excess fluid. Is there pressure that pushing that as well? To the drain?
Yeah, but that is just drainage, that is waste, so that drainage is there within the system. So when you hook up your dialyzer connector, right, it has and remember I was talking about how the blood, the flow of the blood and the flow of the dialysis is opposite to each other. So the blood will be coming from the top by the arterial end going down to the venous end. But when you hook up the dialyzer to the the connectors or the couplings to the side, it's the venous end, the coupling that's hooked on the venous end, the dialysis will be coming in through here, and the drainage will be taking place on the arterial end. So it does work like anterior retrograde to each other.
Okay, I understand. All right, thanks.
You're welcome. Everybody understand that?
Yes, ma'am.
Yes, miss.
Okay, so any other questions?
Miss, I just want to emphasize on something that he said. How Dr. Michael explained it is that positive is when like you're pulling from a straw, and negative is when you're blowing. So if you think about it that way, it will be much easier.
No, is actually he explained it the opposite. The pulling action is negative.
Yeah, the pulling action is negative and the positive action is the pushing action.
Okay.
So the suction is negative, and blowing, I will say it like that, blowing is positive and suction is negative. So remember, pull is negative, and push is positive.
So if we think about it that way, it will be easier for us.
Okay, so someone wanted to go through the water treatment. Anybody have anybody want to go through the water treatment?
Yes, miss. Especially MGF.
So somebody can tell me the water treatment process.
That's from the water supply, right?
Starting from the beginning.
All right, let me see if I can run it.
What's the question, Andre?
That it's starting from water supply, right? In the supply, right?
Yes.
From the rain.
So
Yeah, from
I'm
the
not sure.
rain.
Let's see if I remember it off the top of my head. When water collects rainwater, it it goes through a process, so different processes to clean, to make it potable. One of the processes it goes through is called coagulation, where alum is added to the water and sediments clump together. When this happens, it goes through another process called flocculation, where these sediments which clump together is called flock, sinks to the bottom of the tank, creating sedimentation or sludge. After the sludge is removed, the water goes through a disinfecting process where chlorine and chloride is added, which kills viruses, parasites. After which the water is then stored and awaiting distribution. If the water is distributed to a dialysis center, it goes through another filtration process, which uses a multimedia filter. Well, I can't remember the rest of stuff. I remember the parts of the multimedia filter, but I can't remember what
Okay, yes, Andrew. Yeah, yes, you have it. You just will need to fix your wording a little bit better. So yes, we know when the rain falls, the water contains limestones and other properties, right? And this rainwater is collected into a lake or a reservoir at the water processing plant. Then a chemical called alum is added. Sorry. A chemical called alum is added, and alum is also known as a coagulant. And when this alum is added, due to the fact that dirt and other particles has a negative charge and alum has a positive charge, the both mixed together or reacting together come to a stage of neutralization, and this causes the particles to become clumped together, or what we call flux, right? And with the particles continuing to clump together or fluctuate, right, they'll start to sink to the bottom.
Miss,
And
excuse.
yes.
Could you tell somebody whoever in the back?
Okay, I'll just mute everyone.
Sure, thank you.
Okay, so you all hearing me better now, Mira?
Much better.
Better, miss.
Okay. So you want me to say over something that you didn't understand or something like that? Or you're on track?
No, we're on track. If you continue, we're just irritating.
Yeah, okay, no problem. Yeah, so when these the particles continue to flux together or flocculate, right, it starts to get heavy and it starts to settle to the bottom of the tank, and this phase is called the sedimentation phase, right? After when sedimentation takes place, the water to the top is filtered and then disinfected by using chlorine or chloramine, right? You could use either or if you use the two, and then it is distributed to the general public where it comes to the dialysis center. And at the dialysis center, the first tank that the water goes to is the multimedia tanks. And anybody can tell me the 5 layers of the multimedia tank?
Yes, the first layer is the anthracite.
Yeah.
Second layer is the sand layer. The
Yeah.
third layer is the garnet 50.
Yeah.
The fourth layer,
The fourth layer.
is garnet 12. And the fifth layer is gravel.
Nice, quarter to 1 to be exact, right? So this water passes through this multimedia tank, which is the first tank, right? And well, after all the heavy particles and all the small particles is removed, right? This tank goes through a backwash, right? And the backwash does go down a drain. So always remember you have to put in your backwash, right? And then after the water leaves from the multimedia tank, it goes where? It goes to the carbon tank and then?
The softener.
Okay, I thought it was the carbon tank.
Miss.
I just wanted to make sure I can't talk craziness.
Miss.
No, it's really the softener tank. Yeah?
Where the backflow prevention tank device?
Oh, I wasn't going through the blending device and the backflow prevention device, because
we have
even
to
if you
include it,
when I
right?
write it, you don't write it, you'll still get marks once you have the main tanks, which were the tanks.
Okay.
So I was just skipping it and trying to make it easier for the ones who was getting it tired. But yeah, the backflow prevention device is when right before the multimedia tank. First is the temperature blending valve, then the backflow prevention device, then the booster pump, and then the multimedia tank. Correct?
Yes, ma'am. What do I have?
Okay, I was just making sure.
Yeah.
So I see some hands up. Miss, anyway, do you all want to interject? Miss Destiny, your hand is up. Okay. Okay. So now the water goes to the softener tank, right? And someone could tell me what happens when this water reaches to the softener tank. Miss Jada Jessup, are you online?
Yeah, I'm online. My phone.
Can you speak?
Oh yeah, I'll do my best to speak. This softener tank
Yeah.
is resin in the softener tank, and it has calcium and magnesium, but that makes the water very hard, and so it has to be exchanged with sodium. Sodium is going to be provided by the brine tank, and sodium exchange happens in the water softener so that the water will not get hard, because it will destroy the reverse osmosis membrane.
Nice, great. So what Miss Jessup said, right, was that within the softener tank, it also has a brine tank next to it filled with sodium, right? And the water that came from the multimedia tank, remember, it is hard water because it has calcium and magnesium in it, right? Rainwater has calcium, magnesium, and other limestones with it. So there's an exchange of this calcium and magnesium for sodium, right? So that's what the resin is there for, because there's a consistent exchange of these two things for this one thing, which is calcium and magnesium for sodium, right? And this softens the water, right? And as fast as the resin sodium is used up, it does be refilled. Everybody understand that? So
Yeah.
right. So after the water leaves from the softener tank, remember this tank it also has a backwash system that comes into play. Right? Remember that the calcium and the magnesium comes from the limestone. That is why it is so important at the beginning to say that when the rain falls, rainwater contains the contains limestone, because later on you'll be talking about this limestone, which is calcium and magnesium being removed. And after the softener tank, then the water goes where?
The carbon tanks.
Carbon tanks.
Nice. And what does the carbon tanks do?
It have two tanks, two carbon tanks.
That's
The
for
worker tank.
absorption.
One at a time. So
It
we have
removes chlorine and chloramine.
chlorine and chloramine, yeah. Yes, so the carbon tanks removes the chlorine and chloramine. So we have two carbon tanks, the worker and the polisher. Carbon tank number 1 is the worker and carbon tank number 2 is the polisher. So whatever the chlorine or chloramine carbon tank number 1 did not remove, carbon tank number 2 is there to detect it and pick it up, right? After the after this happens, what is the other step? Also, I think was done when a person mentioned absorption. So the process of the chlorine or chloramine being removed is called absorption, right? Because within this within the carbon tanks, you know that there's activated charcoals, right? And that it has a whole chemical reaction that takes place there, and it absorbs the chlorine and chloramine. Am I right?
Yes, miss.
Yes, miss.
Nice. And after so after this, the two carbon tanks, where does the water go?
To the UV.
Yes,
catch
to the UV
that.
light.
UV light.
Yes, it goes to the UV light. And what does the UV light do?
Kills bacteria.
Nice. The UV light, it goes to the UV light, which kills the bacteria. You understand? And then from here, the water then goes to what? To where?
The
The
RO
arrow.
system.
Yes. Please write, you all don't write RO, write reverse osmosis system, please.
Miss, let me
Because
take it right.
they
Miss,
can't write
excuse. Miss, I
Yeah.
take it right. It in the first instance, and then you could
No.
you could break it
No,
up.
or when you will continuously write reverse osmosis, for every time that you have to speak about RO, you will write reverse osmosis.
Right.
Please do not use those short what is called acronyms
Yeah, but
for your
it is
exam.
a
Because
standard
remember,
acronym.
yes, but remember for exam, right? Unless you write on top that RO means reverse osmosis.
Miss, well, that's what I'm saying. In the first instance, you will say RO, reverse osmosis. And then you could continue your explanation because you're already telling the examiner that you know what is RO. I don't know, but I had learned it too, but I will try not to do that because it's plenty
I
words.
don't know, everybody have different ways in doing things. I'm a person of clarity, so I like to clarify myself every single time that I say something or I write something. So in my instance of writing it, I will never write RO. I will always write reverse osmosis because I want the person to know is that I'm speaking about. I don't even want them to feel I'm thinking something else. So everyone has different ways in doing stuff.
All right, no problem.
Yeah. So it goes to the reverse osmosis system, and what happens here? What happens at with the reverse osmosis system?
A pump forces the incoming water across a semi-permeable membrane.
Nice.
Miss, and also in the system, the water, it have two types of
What the feed water?
water, the
Yeah, the
feed
feed water
water
and the
and the
product.
product water, one on
Nice.
either side of the membrane.
So what it is? Explain what is the feed water and what is the
All right.
product
So the
water, the
feed
difference. Yeah.
water comes from the pre-reverse osmosis treatment, right? So that would have been the water from before. So this
Nice.
water is which will pass through the UV light.
Nice.
And in the membrane, the product water is the water that will continue for the water purification in the dialysis
What comes
thing,
out of the reverse
out of the
osmosis?
osmosis, right? So the
Nice.
water that containing the contaminants is also called rejected water. So therefore that
Yes.
water has to be rejected and sent down the drain.
Nice. Did I hear daddy reject water? Very good. Who, Miss Prince? You know, you see why I just come and I'll tell you, you see, just have some nice answers, and then when they come in to do exam, you just like you don't want to write, and you just know your stuff. So you need to get in love with writing.
All right. Yes, miss.
And after this arrow system, right? The water goes where?
In some thing, the ionizer.
Yes, the deionizer. And what the deionizer does?
The deionizer work as a final polisher for the reverse osmosis system. So in case that the some small particles or contaminants are passed through, the deionizer will pick it up. This process is based on ion exchange, right? And they say most of the system do not use it because of the efficiency of the reverse osmosis system, how it works so effectively.
Yes, and exactly, and if the water don't pass through the reverse osmosis system, right? And they just say just have a few little endotoxins or whatnot in it, right? And the deionizer comes and the deionizer comes after the reverse osmosis and it kills the bacteria, whatever little bacteria, and then this go into the patient. Then it come like you said, and contaminated water out to the patient because the water it didn't pass back through reverse osmosis. You understand? Because where would the dead bacteria or the dead endotoxins go? Right? So that is why they don't use, some systems don't use the deionizer. Right? And after the deionizer, the purified water could then go through two different types of feed, which is what? What are the two different types of feed?
Direct and indirect.
Great. Anyone want to tell me what is the difference between direct feed and indirect feed?
So the direct feed is the water that goes directly to the system. So that is the water from the RO system. After that, I don't want to say RO, the reverse osmosis system, straight to the dialyzer or dialysis machine, right? The indirect water is from the RO,
Indirect feed.
the indirect feed, sorry, is from the reverse osmosis system and the deionizer, which goes to a tank, right?
Yeah.
So that water is stored in a tank. And the water, the tank is made of a certain material so that it wouldn't leach anything in the water itself. Right? So remember that is purified water we
Yeah,
have there
so
and we
that it
want
will
to keep
have
it purified.
biofilm.
Right? And the
Yeah.
shape of the tank is a cone shape. This is because for when the cleaning of the tank, everything will come out. You see how a cone is shape of the bottom, right? You know how we cone shape. So this water will stay there. And as the water goes wrong in the RO system, water goes back to the RO system or the deioninizer system, it becomes purer and purer in each cycle. That's from the direct feed, right?
Yes.
And the indirect feed. So that's all I
Yeah, so
had
the
for that.
direct feed, the water becomes purer and purer because it goes, if you remember like this, it goes from the reverse osmosis to the machine, and the unused water goes back to the reverse
The reverse
osmosis, right?
osmosis,
And comes
yeah.
back. So it continues to go in a loop. And with the indirect feed, the water goes to from the arrow, it goes to a tank first, a storage tank, and then to the patient. And the unused water goes back through the
Goes back
reverse
to the
osmosis
reverse
system and
osmosis
comes back to
system.
the tank and then goes back to the
And the
patient.
cycle continues,
Right?
yeah. Yep.
So right, so that is the water system. So everybody understand the water system.
Yes, miss.
Yeah.
Yes, miss.
Okay. And I just want to know, a student called me, right, and asked me, she said, Miss, seeing that you're making 5 marks if you pass the exam. If you make under 70, you'll get like 1 point at least or something. No. Under 70, it doesn't get no marks, nothing. Zero, zip, zilch, F, fail, right? I just putting it out and telling you guys because I know that there are students outside here thinking that even though you get 70, you're still going to get you're still going to get some marks, so it will not make up in the 40% because you ain't getting no marks. Nobody doesn't even get a full 5% mark because 5% means that they get 100 out of 100. You understand? So like when you get like 95 to between 95 and 90 and 99, you'll get like 4.5%. If you get it like 90 to 95 or something, so you'll get 4%, I think 70 to 75. I think that is either 0.5% or 1% or something like that. But I know it's really messed up that it doesn't get no marks if you fail, right? I just wanted to clear that for the ones who was thinking about and asking questions.
Sarah, how
Yes.
much marks you say it is get? If it is, you get between 70 and how much? Between 70 and what? Repeat that.
That's how I'm looking for the paper. Honestly, to tell you, I'm looking for the paper right now because I had it to write down because the student asked and I went and asked about it and I got it. I think it's like only 0.5% or something like that.
So if it is, you
Not
getting
even a
point. If it
1%.
is, yeah, but that's
Or
But
crazy, no, because
70
if
1%
out
it
of
is,
something.
they market
5%,
you.
that's
If it is,
3.5. 70 out of 5% is 3.5.
3.5. Okay. Wait,
or because
just
I now going to say if it is the pass mark is 70 and
I know
them
it has
only
something
giving you
with
point something,
0.5%
that
or
is
something.
craziness.
Yes, But
So
under the 70, you're not even getting 1% or nothing.
no, well, I could understand under 70 because the pass mark is 70 and above. So I could understand under 70. But if it is you get 70, 71, 72, 73, and you only getting point something, that is madness.
But then that still don't make no sense because they said that each exam is out of 5%. So whatever mark you get, it should be added.
Exactly.
So each exam is out of 5%, right? And then out there you have 8 exams. So 8 by 5 is a 40%, right? But if you're making like in the 70s and thing, you think that is so much? I don't think it's so much. I had the paper, I didn't think I see so much.
Well, 50
The
out
school
of
explained
100.
it to you?
Yes, that is what they explain. That each.
Oh, okay, no problem.
Okay.
Because I was thinking that, even though I wasn't make under 70, they'll get at least a 1% or something like that, so it was nothing like that.
They explain that each exam carries 5%. So I think whoever is a grade, you get out, you work it out of 5%, and it might be low.
Okay, yeah, I think 70 to 70, 70 to 76 is like something like 3.5%. Something like that. 3%.
So basically what you're saying, anybody that go under 70 for the past 3 or 4 exams, they haven't got anything but 0 until the pass exam?
And it says fail. Under 70 is fail.
Miss Sarah, so do they
You
have a
need
system put
70
in
to
place?
pass. Excuse?
Yes. Do they have a system put in place to like extracurricular or like a makeup exam or projects or something to put in place to help the students get the passing grades for the theory parts?
No. The says that when you go to externship, but nobody ever made 60 in the externship. I made 59 point something in my externship. Just the fact that I was really, really good in my theory, and the nurse, when the head nurse examined me, I told her things that she and all didn't even know. She was really shocked. So that's why I made so good. I made the highest mark ever in practical in the IME because I was really good at my theory. But nobody ever does make that. I could have passed, I would not even pass if I didn't have my theory marks because I made 59 point something. You had to make a full 6. Or I think the last pass is 50% to know. But the point is you have to get over 50 in the practical. You understand? To pass without passing any theory.
So when you pass your theories, how much you need in your practicals in order to,
So much
pass
about to
it,
make up
basically?
50% in the end.
Okay. Oh, it's out of 50. Okay.
For the
No.
overall percentage for the exam, both
So the
theory and
overall
practical.
percentage you're telling us is out of 50 or out of 70? Because I know for the exam percentage is out of 70%, but
70,
overall percentage is 50.
Okay.
If this is exam number 4, then you have 4 more written exams to do. For the person that asked him. Okay, so I just wanted to clear up that a little bit. So anybody else with any questions? So did you all do your words and meanings? Like definition?
Well, what's that means?
Like what
you
I
mean
told
like
you, Tiffany, but you had it though.
what? I
What
don't know
is
what
an
you're talking
acid?
about.
What is a base? What is pH? What is a buffer? What is conductivity? What is
Okay,
the
yeah, I have that.
Right. So you all know how to calculate osmolality?
Yes.
Yes,
Yes.
miss.
Yes, miss.
Great. And you all know how to calculate URR?
Yes, miss.
Yes.
Yes, miss.
Nice. And you all know that if a patient dehydrated with saline, you will get them.
0.45.
Nice. Woo! Yes. Don't go giving that patient no 9 saline, you know, because patient will get more dehydrated.
Yeah.
Nice.
What's
And
that?
everybody know about sodium modeling.
Yeah.
Okay, so what is sodium model? What is sodium modeling? What is the contradictions and with sodium modeling? The indications and contraindications of sodium modeling. I have it here in the handout.
Miss,
Yeah, miss.
intradialectic hypertension.
Mm-hmm.
And you do sodium modeling for patients that usually have hypotension.
Yes.
It's basically where a sodium concentration in the dialysate is gradually adjusted during the session, starting high and decreasing over time.
Mm-hmm.
Nice.
It also helps to manage sodium balance, and an indication is also cramping.
Yes. Yeah. Cramping, because you know that when a patient pressure is low, they just get cramps, right?
Yeah.
When there's no salt
Nice.
in the patient. Yeah.
Yeah.
A decrease in sodium.
So not
And
only when it's a yes, Tiwana, go ahead.
contradictions are uncontrolled hypertension,
Mm-hmm.
hyper. Miss I could never say that word
Hypernatremia.
properly.
Hypernatremia.
I could spell it though, but I always pronounce it wrong.
Nice, well, right. But I know it was that you was going to say hypernatremia. Somebody want to say what is hypernatremia? Tiwana, you have the definition of hypernatremia for the ones that don't know what is hypernatremia.
High concentration of sodium in the blood.
Mm-hmm.
Nice. Great. So everybody understand this whole sodium modeling thing. Everybody?
Yes.
Yes, miss.
Nice. And what are some factors affecting potassium removal during dialysis?
Say it again.
What are the factors affecting potassium removal during dialysis?
Beta agonists.
Acidosis.
Metabolic correction of metabolic acidosis as well.
Mm-hmm.
Okay, that's 2. We have 8 more. Somebody else. There are plenty people online and I'm only hearing 4 and 5 students.
Glucose in the diacylate. Diacylate.
So what you miss who is answering?
Yes, miss.
That person was saying, yes, your answer eventually would have been glucose containing dialysate versus glucose free dialysate.
Yeah.
Okay, somebody else, can I have another factor
Okay.
Correction of
affecting
metabolic
potassium? Miss
acidosis during
Angeline, can you give
dialysis.
somebody else a chance?
Sure.
A dialysate high in potassium cannot remove excess.
Excuse? Repeat? What was the next answer? Miss Annalie, you are saying something, Miss Annalie Pierre, and then Stephanie
Correction
after.
of metabolic acidosis during dialysis.
Yes, somebody said, Miss Annalise, somebody said correction of metabolic acidosis during dialysis. So,
She
so
said a
far,
dialysate with
Anybody
the
said
high potassium cannot pull the
hypertonicity?
potassium.
excuse? Yes, exogenous insulin, that is one. So far we have exogenous insulin, we have beta agonists, glucose containing dialysate versus glucose-free dialysate, and we have correction of metabolic acidosis during dialysis. What are the other factors affecting potassium removal?
Blockers,
Beta blockers,
hypertonicity,
What is the point?
as hypotonicity, hyper, hyper, hypertonicity, right? We still have 4 more
It's a
factors.
alpha adrenergic receptor stimulator.
Alpha adrenergic receptor stimulation.
Stimulation, yes.
Nice.
Is a remove potassium.
Nice.
Help
And
remove potassium.
Nice. And what else are we missing? Okay, that's it.
Miss, excuse, have somebody in the waiting room.
Okay, so that's that they just got bumped off. Okay, I guess you all are prepared for this exam. Please do not go writing short answers and expecting big marks.
What is the problem?
Anybody else has any questions?
Mm.
So what is a
You could go
compound?
through filtration and ultrafiltration, please.
Filtration and ultrafiltration. Mm.
That's a question. Somebody was on the case.
Oh, okay. So I was talking and my mic was muted. Right. So ultrafiltration is just ultrafiltration. That's the dissolute drug that you're speaking about.
Okay.
I'm asking.
As a student that wanted to know for you to explain that. But that
Okay,
is
so
the
the
same as drug,
ultrafiltration comes under convective transport.
Right. Yeah.
Okay, so ultrafiltration is convective transport, right? Where water moves across the membrane because of a pressure gradient, right? So the water is being pushed across the membrane due to the gradients.
To solvent drag.
So it does have like an effect. It does have an effect. With this pressure, it does have an effect on the solute, so the molecules within, right? And by the pressure it does cause the solutes and particles, whatever is floating, to go across with it. You understand? So it's the water pulling across the membrane, and it is also pulling particles. So this ultrafiltration will lead to or convective transport. You understand? It carries the molecules across the membrane, and this is known as the solvent drag.
Okay, miss. I understand what conductive transport is too. So
remember that remember convective transport means carried together. So water carrying the solutes or the molecules, solvent drag
like
across the
water and
membrane.
sand. Like water and sand.
Yes.
Flushing.
But remember, it have a pressure gradient. What is the ultrafiltration? Pushing the ultrafiltration is the pressure gradient, right? Pushing the water across the membrane. Right? So it have page 27, right? Page 27 on ultrafiltration. The pressure ultrafiltration is the pressure necessary to maintain blood flow established by a hydrostatic gradient causing fluid to cross the membrane. You understand? So you see that hydrostatic gradient, that hydrostatic pressure, right, causing the fluid to be pushed from one side, semi-permeable membrane, to the other side. That is called ultrafiltration.
Okay, miss, thank you.
Anybody else have any topics?
Miss,
Yes.
with the URR and the KTV formula, the KTV is the one with the 1.2, right? Or the URL?
Yes.
I get mixed up with
KTV is the
thing.
URL. Yes, it's clearance. What you have to remember is what K, T, and V stands for, what the K stands for, what the T stands for, and what the V stands for. Clearance. Somebody can tell me? K stands for?
Time and volume.
Right. But then have URR, which is the urea reduction rate. That is what you have to learn to calculate, But yes, the KTV shouldn't be less than 1.2.
Okay. All right. And the 62%. All right, cool.
Miss,
Yeah, you all have the URL calculation?
Yes, miss.
What is the URL calculation? The formula.
Pre-BUN, post-BUN, post-BUN over pre-BUN, and then the
Okay, so the
URL will be 1
post-BUN
minus.
divided by the pre-BUN, that BUN will give you the R, right? And then to find the URR is 1 minus the R divided by 100, and you get the URR.
Yeah.
Excuse, sorry, could you repeat
We
that
are
again,
multiply by 100.
It's multiplied by 100.
Yeah, we have multiply by 100.
Sorry, multiply by
Yeah.
100. Sorry, I said divide.
Yes,
I said
Miss Eden.
divide, I'm sorry. It's multiply by 100. Right?
You,
So,
that is,
if you have a patient and your patient came in, excuse? I was
no,
going
go
to do an
ahead.
example.
I'll ask you after. Go ahead.
No, go ahead and ask a question.
No, I was want to ask you about something else. The complement system. I don't think I really understand that too much.
Okay, we'll go through that.
Okay.
Okay, I'll just making sure I get this correct because 1 minus 779 multiplied by 2.5. Okay, right. So you have a patient and your patient come in to the beginning of dialysis with a BUN of 150, right? And after he finishes the dialysis, his BUN went to 110. What was the value of his urea R?
What was the pre-bun?
The pre-bun was 150 and the post-bun is 110. Ms. Ramkaran, your hand is up.
You can mix it them up.
Yeah, I feel like my calculator going crazy. No, that's not the answer. Anybody else? Anyone else got that answer? If your pre-BUN is 150 and your post-BUN is 110, what is your R?
27.
Miss.
Well, it are
20. What is it? R?
zero
Or you are
0.7.
Point.
That's what you have.
0.73
for R.
Right, it's 0.73.
Yes. Okay, I write in it 0.73. I type in it in the chat, okay? Right? So R is 0.73 because I'm typing in the chat here, online here. It is it is post divided by the pre-BUN. Right? So 150 divided by 110 will be 0.73, right? And next, what do we have to do? What is the value of the URR?
1
right?
minus the 0.73.
So we have 1 subtract 0.73.
Which is
I'm typing here in the right? 0.73, which will equal to 0.27. 0.27. Right? I'm typing. And when we get this 0.27, we have to multiply
by 100.
by what? By 100. So this 0.27 multiplied by 100 will
Must
give
be
us
27.
27%.
27%. And what is the satisfactory? So that'll be 27%. Sorry, I forget to write the percent. So what is the satisfactory URR percentage?
65%.
65.
About
Right.
65%.
So if this person gets 27%, was that satisfactory?
No.
No, it wasn't. So, do I want to do the next one?
Like something wrong with my calculator because my calculator doesn't make sense.
Yeah,
Very
miss,
wrong.
because my calculator, when I do 150 divided by 110 again, 1.36.
I'm 2 again, 1.363.
It is 110. 110 divided by 150. And you'll get 0.73.
Post over the
Post
pre.
over the pre, yeah.
Yes. Oh, I
Is
put
that no way
150
right?
divided by 110. Wait, let me delete this. This was wrong. I thought I said, but it was 110. No, I'm going to type it over. It's 110 divided by 150. Okay, so.
Yeah, I want to know like.
Right, but I said the post divided by the pre-bond, and yet still I put the pre-bond over the post-bond.
Oh Lord.
Now this is easy ways that you can just make mistakes in exams also, right? You see how simple that was? And writing my whole question went down the drain and I get 0, even if I get the right answer. But you still get marks for having make sure and write down your formula. So you all want to do our next one, everybody understand?
You want the next one, miss?
Next one, please.
Yes,
Let's do next one.
Okay. So, okay, you want me to type it? Your pre-BUN was 175, right? And your post-BUN was 90. Find R.
R is 0.51.
Yeah. That's no mirror. We calculate it now.
0.51. 1 minus 0.51 equals 49.
So we still on the R. Right? So the R is
49.
what is the R?
The R is 0.51.
Okay, and how we got 0.51?
90 over
90 over
175.
175.
Yes. So it is 90 over 175, right? Which is equal to 0.51, right? So now we want to find the URR. What is the URR? The URR is 1 minus 0.51.
0.49.
So your answer is
0.49.
So the ones, anybody who looking for it, I type it in the chat as we go along, right? Right here on the chat, right? So we have 0.49. And what we have to do with this 0.49?
Multiply by 100.
Multiplied by 100. So 0.49 multiplied by 100 is how much?
49%.
49%.
So did this person get a good clearance?
No.
Is it acceptable?
No.
Nice.
Miss, could give
So,
us.
seeing that we know how to, yeah?
You could give one on osmolality when you finish.
Okay, I think it's, wow.
Think to work out.
Okay, well, when we finish KTV. Okay, so let us finish with the KTV, right? Everybody understand KTV so far? Can I see a raise of hands? We have 43 people online by raise of hands. How much you understand?
I can't find this hunting, but yes.
Okay,
Just
so we
click
have
on the
right.
reactions.
We
The
have
one that
I don't understand the KTV.
who don't understand KTV?
Miss Medina.
Okay, so I see 20 people had their hands up. You can lower your hands now. Miss
I
Medina, you
understand.
do not understand KTV?
No, miss.
Okay, so what we just went through was the calculation of URR, right? Which means the urea reduction rate, also known as clearance, right? So what is meant by KTV? So K is the dialyzer urea clearance in millimeters per minute, right? So K is the clearance. And I would like when you are writing for exam, please write out that. Just don't just write K is clearance. Please write K is the dialyzer urea clearance, right? In mLs per minute. T is the dialysis time in minutes, and V is the volume of distribution of urea in the body, right? So there's a calculation to find out the urea clearance when a person does dialysis, how good the clearance was. So to find this clearance, right, which is what we call the urea reduction rate, right? We have this formula, and the formula is post BUN over pre BUN to find the R, right? But for you not to get mixed up, let us start by what equals URR. So URR is 1 minus R over 100 multiplied by 100, right? But to find R, we know that you have to divide the post BUN by the pre BUN. So you cannot find URR unless you find R. So that is why we did R first. You understand what I just said?
Yes, miss, I understand.
Yes.
Good. So you have your URL formula is, I'm going to type it in the chat so you could write it down one more time without examples. So URL formula, right, is 1 minus R multiplied by 100, right? And to find R, it is the post divided by the pre BUN. So that's the whole formula there. So everybody with me, right?
Yeah. Yes, Miss. Thanks very much.
You're welcome.
Okay.
Okay, so we have 10 minutes. Somebody wanted to go through go get the formula of osmolarity, sorry. So somebody could give me the formula for osmolarity.
Miss, before you move on, you could just give me the proper definition for tea. The proper definition for tea. Your time?
Time in minutes. The time, T is the dialysis time in minutes.
Okay.
Miss, you hear me?
Yes, I'm hearing you. Shania.
Okay. A formula for osmolarity. Oh my God.
Osmolality.
Right, is 2 multiplied by sodium plus 1 over 2.8 plus glucose over 18, which will equal to osmolality.
Yes.
Sorry, I can't pronounce 02 properly.
Okay. I want to find the page on the handout for the person that just asked because I saw it in the handout.
Yes, I know the formula. I
So
just
on
want.
page 13.
Yes. Hi.
Yes.
I know the formula. I just wanted you to give us a question on it.
Okay. Just 1 minute, sir. Okay, I find it. Okay, so if a person has a glucose of 600, let me type it out. Right, the glucose is 600. Huh?
If I start to the sodium first.
No, I just put in all the information what you will need. Right? 600. The BUN is 85, and the sodium, also known as the Na, is, let's just say, 160. Right, so let's put some pressure real high. Okay. So the formula, you want me to work it out too? You want me to work it out with you guys as I give you it?
Miss, what's the B1?
Look at everything in the chat.
I'm not seeing
Everything in the
anything in
chat.
the chat.
Miss, I don't think you press send because I did not
I'm not
receive
seeing
it
it.
on the Zoom chat.
The chat on the chat right here on the chat right here on Zoom.
The last thing you did was the 110 divided by 150. I'm not seeing nothing else.
So in the tutorial chat, you are not seeing it? Anything? Oh, just now. I see what is happening here. Just now. I'll have to resend to everybody.
383.68.
Mercy BUN over what?
BUN
2.8.
2.8.
Yeah, I'm sending this just now. I sent it over the whole thing. I did send it, but I sent it to one person or something like that. So that one person got it in the chat. The BUM was 85. So you all seen it now?
Yeah.
Yes, Miss. Miss,
So what's
the
missing? The
dose is
glucose.
600, right?
Yeah, the glucose is 600. Okay, so we have our formula, and you always remember you have to write your formula before you start anything. You understand? Because this is what does give you points, right? So your formula is 2 sodium plus BU, the BUN divided by 2.8 plus glucose divided by 18. Right? This is equals to osmolality. Okay, so everybody see that in the chat.
Miss, I not seen anything in the chat, you know, but you could call it out.
In the meeting
Yes, yes,
chat
I've
right
seen it in
here.
the chat. Yes, I've seen
Yes,
it. I've seen it now.
Destiny, what is this answer? We're going through it step by step.
Calculate it all one time. You have to calculate it separately.
Well, we're going through it step by step. So we're going through it step by step. Right? So we don't want the full answer yet. Right?
Okay.
I don't want to confuse anyone, right? So for the ones, the formula for KTB is higher up. Stephanie, it is higher up in the chat, right? So right now we are going through osmolarity calculation. So you can just scroll back up in the chat and you'll be seeing the KTV calculation. Well, it's not KTV. We're not doing formula for KTV. It's called the formula for URR. We are not. Everybody with me because you all seem tied up. Right now we are doing osmolarity. KTV do not have a formula. It is the formula for URR. Everybody hearing me?
Yes.
Yes.
I thought I was speaking to myself.
Yes, Miss. Miss, one question, right?
Yes.
When I calculate any osmolality, right? You're getting it like in a
Osmolality.
whole, like a long decimal. I'm not too sure what Silver want us to do, but
So that's why we was doing it one by one, right? So you have 2 sodium. So 2 multiplied by sodium, that is 600 multiplied by 2, right? That is 1200.
Miss, you put sodium.
I thought
I
sodium was 160.
Oh, sodium 160, sorry.
And
Sodium is 160
600.
multiplied by 2, right?
Yeah.
So this is 320, right? And
Yes.
then the BUN is 85, right? So we have the BUN is 85 divided by 2.8,
Yes.
which is 30.
30.35.
30.35, right? And the glucose is 600
600.
divided by
33.33.
18. Right, 33, which is 33.33, right? So adding all of this together, which is 320 plus 30 388.35 plus 33.33 is 388. I mean
Plus
383 plus 0.68.
Yes. Okay, I got that answer correct.
So that will be your osmolality.
If I know nothing else, I can
So
calculate
your
those two.
normal, your normal plasma osmolarity will equal 225 to 290. So osmolarity like this would be like too much, right?
Yes.
That's why I say in the you know it'll be
It
too
was
much.
very,
Same your patient
glucose
pressure
was
will be
very,
real
very
high.
high.
It's 270 or 275?
383.68.
No, I mean the normal rate.
275 to 290.
Okay, Tom.
So your normal range of osmolarity is 275 to 290. What is the difference in osmolarity and osmolarity?
Osmolarity is in kgs. Osmolality is in liters.
No, osmolarity is the
Yes,
amount of sodium in 1 liter in a 1 liter solution, and osmolality is the amount of solutes in a 1 kg solution.
yes. Osmolality is kg and osmolarity is liter.
All right. Mix it up.
Please don't mix it up. You know the difference, so you have to get some maths. Right? I'll send a definition for you guys in the group.
Osmolality, kg?
Osmolality is kg per solvent.
Yes. kg of solvent.
And larity is solution.
Yes. Liter of liter.
Solution.
Yes. So the osmolarity is the number of osmoles of solute per liter of solution, and osmolality is the number of osmoles of solute per kilogram of solution.
Number of particles. I have particles, so that could work also.
Yes.
Okay.
Okay, so we cleared basically everything. So anybody else have any other questions? It's now 8 o'clock. Anybody need any help, you can message me. Any more questions? I guess nobody has any more questions.
No, miss. No more questions.
No.
Excuse?
I said thanks for the help and the clarity.
Okay, so everybody have a wonderful night. Anybody need any help, any questions, you want message me. I will help you guys, no problem.
Thank you.
Thank you.
Okay, everybody join it. Bye.
Bye.
Bye,
Good luck
miss.
in
Have a
exam
nice night.
Saturday.
Yeah.
Good luck, everybody, on Saturday.
Yeah. Same to you.